So today we are going to see a couple of more policies, including that are shown here in pink color. This one, IP block list, allow list, header injection and header removal. What are they, and how to implement them? We'll see also JSON thread protection and XML thread protection. Then after that, yesterday we saw just theoretically the order of policies. Today we are going to see hands-on, apply policies, reorder them, and see how the message logs behave. And I have a couple of questions. We will also see automated policies. And finally, we will see endpoint with proxy. And I have also Kahoot questions. So after we got up to endpoint with proxy, I will give you 10 minutes break, and then we will cover endpoint with proxy and Kahoot. So let's get back to here. So yesterday, I'm logged into endpoint platform as you see, and we saw applying different policies. This one I have deployed, I will show you later. So it is this application, W3 Schools application here, and under policies, this one, let me remove it. I was just testing, so we'll remove it and we'll see it together. Remove policy. So we saw these ones: spike control, message logging, client ID enforcement. And so the client ID enforcement, let me show you the configuration. This one, we have, this is custom expression, and we are passing the client ID and the client secret as query params. And if I have them here as query params, as you can see, when we go to params here and put key and value, here, key one, and value one, you see Q1 and value one is being added here. So if I uncheck this and send request, I get response, as you can see here. But if I check this also, I get response. I can also add other keys, key 2, value 2, which are not required, but still I will get response. And this is not really good practice, because bad actors can break your application, make it busy, consume more resources by adding unnecessary headers and query parameters. Like they can add very big query params and payloads in the header or in the query parameter. And there is in API Kit Router what is called query parameter and header strict validation, so that it checks only if the required, it checks that only the required headers and query params are being set. If additional query params and headers are being sent, then it gives an error. And so that is important, even if it is not in API Manager. I just wanted to quickly cover that. And that one, we do it in our implementation here. So let me close this one for now. And our W3C Schools implementation was, where is this? Which one was it? I guess it is this one, design, develop, deploy one. Let me check. Okay. So let me go to Runtime Manager. And this is API, W3 Schools API. Did I delete it at some point in time? Okay. I guess probably it is that one. We were working on this one. So let me try to deploy it and let's see if it says it already exists. I'm not sure if it will say that. So this is different. Okay, deployed Cloud Hub. And we can even just test with this one. It's still fine. Cloud Hub. So here was a problem. I can't use underscores. Yeah, okay. We can test this one, no problem. Let's just even test it locally. We don't need to push it to Cloud Hub. I mean, it is the same, it will have the same impact. So I will open this, let's say the implementation. So this one, it just returns W3 schools data, and the data sets are under this folder. We have been working on this. You can get it from the previous classes, from data with class 9, and also from the design develop deploy starting class 1. This is the implementation. This is the interface and global configurations. We put them here according to the best practices and error handling. We have this. So let me quickly run this. What I wanted to show you is if we just run this and let it get deployed, then we are going to test it by sending query parameters, and we will see if even if we add as many query parameters as we want, even query parameters that are not important, it will still give response. It will not fail. But what we want is the API kit router. We want it to validate if only the required query parameters and headers are sent. Otherwise, it should fail, because this protects your application from getting crashed. Okay, so this has been deployed, as you can see. And okay, let me clean the console. So if we go to the interface in the listener, we have this API, and here it is get with W3 schools. So, and it expects query parameter, because in the implementation, we have attributes.query params.data is the data we want it to read and send back to us from this data sets. So let's quickly do that. Send requests. We have localhost 8081 API W3 schools question mark data orders, for example. This one will give me orders. Authentication denied. Oh, okay, because okay, so the other thing also that we want to cover is if in your implementation, even if it is in your Anypoint Studio, if you have added auto discovery, the policies in Runtime Manager will be applied to your local implementation also. So it needs the exact implementation that you have in the cloud. So from this one, let me remove auto discovery so that it doesn't apply the policies. If you see here, we will see somewhere that you see here runtime logging policy. See here, and the size of the returned payload is 1. This was what we were looking at in API Manager yesterday. So if you just deploy an application without auto discovery, which doesn't have an API instance in API Manager, you don't see these details. But if you have auto discovery enabled, and if you added the ID, that means your implementation, even if it is in your local version, it can it downloads the policies. So from here, I will remove, go to global, and I have API auto discovery. So this one, I will remove it and stop this and save it, and maybe close it and open it. Okay. So now it doesn't have any more communications with API Manager. So now run it, and I will clear this in the meantime. Let's see, let's make sure it is not applying any policies. So if it applies any policies, you have to add the credentials. That means we could also have added the client secret and the client ID. So now Okay, clear here. Okay, perfect. Now there isn't any policy applied because we disassociated them. Okay, so now I can send requests. I just wanted to show you how we can control unnecessary headers and query params from being sent to your application, because that could cause problems to your application. See, now I have this data, orders, purchases, purchases. Okay, let me see. Do I have purchases here? Oh, okay, I don't have. Oh, I have products. Okay, no purchases. Let me check products and so on. So this one, we have been testing it many times and it works fine. Now let's add more keys. Like I would just add unnecessary keys, key 1, value 1, key 2, value 2. This is the query params are being added here. So if I send this request also, it is going to still work because it just in our implementation, it checks the presence of the data query parameter. It doesn't care about the rest. So if that is the case, if you add more here, you can make your someone can make your application to be slow and to crash. So in the API kit router, there is what is called query parameter and header strict validation. So let me show you. You come here and this configuration, edit it, click edit. Okay, sorry. Yeah, here it comes. Okay, perfect. See here, there is query parameters, strict validations, and headers, strict validations. From now on, in our next classes, when we develop applications, when we are going to enable these ones, we will select these ones. So now, if I select query parameters strict validation, when I add additional query parameters that are not required, it is going to the API kit router will block it. It will just respond an error. So let me save these. And let's see if it is updated. Okay, yeah, this purchases is data that doesn't exist that I was sending. Okay, let's just try to send requests now. Does it still work? Okay, maybe I have to restart it. Stop, run. So you get it in the, basically, you get it in the configuration for the API kit router. And it helps you to control and unnecessary parameters and headers. So we'll do this quickly and continue to our API policy applications that we have been working on. Okay, perfect. Okay, successfully started. So now, if I send requests, it should. How can it is free? Wait, how can it is working? Let's see. Did I apply the configuration appropriately? Oh, okay. This one I didn't save it, maybe. So query parameters strict validation, unfortunately. So I have to do that again and click OK and save. Let's see. Now I'll come again to the configuration. This configuration for the router. Edit. This one is now checked. Okay. So I may not even need start it. Okay, so let's send requests now. Send. You see bad request. Now, if I unselect this one, it will work. But if I add additional key, it will say bad request. So remember this, okay? With headers also, you can check the same way. We just check it with query params. With headers, when we have headers another time, we are going to check. So that is one thing that I wanted to cover. So now let's see about these different policies. Let's start with this IP block list or allow list. So our whitelisting or blocking a single IP or a group of IPs, especially if it is in a company, it could be a range of IPs that you allow, or it could be a range of IPs that you block, or it could also be single IPs. So I can show you in my case. So policies, let's go to API manager, and so this is the APIs that we have been working with, and the policies. Let me first send a request and show you that it is working. Then I will block my IP and it should fail. So it is this one. Let me remove this one so I don't need them. Sorry. The query param validation, yeah, from the API kit configuration. So in the interface, you have this API kit. So you have this router configuration in the drop down here. You can either click here, edit, or you go to this global elements, the configurations that we put under global. We have router configuration here. This one also you can click edit. And if you scroll down, there is this, okay, this one, query parameters, strict validations, and headers, strict validations. So this should be checked. We just checked the query parameter strict validation to answer your question as well. Okay. Now, let's test this API. So we tested this one yesterday by adding query parameter, the client ID and the client secret, passing them as query parameters. Because in the policies, to show you again, here under policies, we are passing custom expression and client ID and the client secret are expected as query parameters. So we are testing it this way. So if I click send, it is working as you can see. So for this application also, to have query parameter strict validation, before I deploy it, I have to make sure in my configuration that it's checked. So right now, if I just add keys, it will still work because we didn't add that when we deployed it. Okay. So now let me block my IP. So what you do is you just type what is my IP. In my case, this is not my real IP. This is an IP in Canada. So I use what is called, if you want, there are tools that hide your IP and they give you a fake IP from somewhere, like, so that your online presence is hidden. So anyway, I will block this IP. So copy this. This is in Canada. Later I will change it to somewhere in the US. Okay, so don't worry. It is not an IP that I will continue using. So add policy and security. If we go here, where is it? IP block list is here. Next, block list IP. So data with expression for extracting the IP address from this IP request. This default, I will leave it because the IP will pass in the headers. So list of IP addresses denied from API access. You can add one or several IP addresses or define a range. It says here, we're just blocking one. The same thing in the advanced also. Do you want to block it for specific messages and resources or for all of them? I will just apply for all of them and click apply. Okay. So now let me duplicate this and go to runtime manager, see if the policy has been applied. Runtime manager. This is the application. Go to logs. So this is live console, so it will update itself. You see here, the policy has already been applied. Applied policy IP block list, says here. So now let's test. And see, the IP address is invalid, it says. It is because I blocked this IP address. So, and if you block every IP address, you can whitelist a couple of IP addresses also, the same thing. So that is blocking and whitelisting IP addresses. Let me remove it now. I don't need it, just for demo purposes. Yeah, remove. Just click on the three dots and remove it. Now let's see the other policies very quickly. So now let's see header injection and header removal. So what are they? So header injection and header removal, let's add those policies, add policy. Let's start with, let's see just header injection. Header removal is opposite of that. So go to, this is transformation. You are transforming either the attributes or, you are transforming the attributes, the headers. So you go here under transformations, we have header injection and header removal. So select header injection. This means you are just adding a header. So here we see inbound header. This is, you are adding header to the request before it goes to the application. Or outbound header, this is after you get the mail event from the response. After you get the response, you are adding a header to it, so that an additional header is visible to the client. So let's add one inbound header and one outbound header. So this one, the key, for example, let's just call it version of API, and I will just add v1. This is in the inbound. And in the outbound, let's see, for example, let's get the size of the payload. So you will see this in the header section. So size, and here query params, like we do this to make it expression, then size of payload. Make sure, okay, yeah, the second square bracket, I should not forget it. So here you can put data with expressions for both the keys and the values, but I'm just hard coding them. As you can see in the first one, just adding version v1, the version of the API. So assume this is going to be sent to the downstream application if we have network of applications. And this one is a response to the client. So apply. Sorry, let me edit configuration. Size of payload. Did I make a mistake here? So this one makes it. Oh yeah, only one. Thank you. Okay. Save. Do we? Let's see this header injection. Where is it? Yeah, so this size of payload is this part. So this is fine. Now I put my data with code here. So this is good. We just need one square bracket and save it. And let's wait until that policy gets applied. Here you see here, applied policy header injection. So now when I send request, I should get in the outbound header, I should get the size of the payload. If you come here, it doesn't show size of payload is header. Yeah, actually, we didn't see this, but it was not showing. Under header section, you see we didn't have any size key with some value. Don't have that. Now we will get that. Send. You see size 10. And if I make this employees to product is, now I should see size. Where is it? 77. And there is, where is it? Size 196. So this is header injection, basically. That's header injection, and it is found under, in the policies, it is categorized under transformations. Under transformations, we have header injection and header removal. You can also remove headers the same way. So that is header injection and header removal. Now let us see this one. JSON thread protection and XML thread protection. Did I add? Let me show you. I thought I added some links somewhere, but I lost them. Okay. Anyway, let me search it and I will add hyperlinks. So it is this one. It protects inflated requests, like in the JSON, bad actors, they could send complicated JSON, more nested JSON, or deep XML that could create problems in your application, and you want to have some restrictions on what could be sent so that unrequired complexity is not included in the request. So this is JSON thread protection. Copy it and just link this. So let's read this together. So this says applications processing JSON requests are susceptible to attacks characterized by unusual inflation of elements and nesting levels. Attackers use recursive techniques to consume memory resources. See, so we are trying to solve this problem. Dramatic swings in the size of the applications, the application data often signal a security problem. The JSON thread protection policy helps protect your application from such intrusions. So you can read this. Now let's apply that. Okay, so same way. I have another application. Now we are not using the W3 schools application. I have a dummy application. Push it to Cloud Hub. Let me show you first in Design Center what I have, the RAM specification. Then I imported the RAM specification and deployed it. Okay, let's go to Design Center. So basically what it does is it returns whatever data I give it. So if I send JSON, it will return that payload. If I send XML, it returns that. In real world, when you send some data, for the data is to be inserted to some data store or some database and so on. But just for the demo purpose, in this case, I have these two resources, I guess, yeah. Data JSON and data XML, and the messages are, I just have put for both of them. So this is JSON. I have put a dummy example JSON. In this one, even I didn't include an example for the XML, but we can do that also. So I just imported this and created, let me show you. I just imported that and JSON XML, it is this one. This one. So basically what it does is in the transform message here, it just returns the payload. See, you send a payload with the put method, and the last payload is the payload itself. The payload is sent. So it will return that original payload for the data JSON resource, as you can see. For the data XML also the same thing. The only thing is now this one will change to XML. And the payload, since it is XML, I don't need to add root node or stuff. I just make just payload here. So this one, it returns whatever data I give it. And I pushed it, I deployed it to Runtime Manager. Let me show you. It is this one. XML, JSON XML thread protection. And the same way I added an API instance for it in API Manager, and I added auto discovery with the API ID and added client ID and the client secret. So I have this one. Should be working. Basically, all these steps we have seen, but there is no policy applied, I think. And if there are, I will remove them. Okay, this one is we can edit. We can just edit them and see them together. Okay. First, let me disable it. Let me disable both policies. This one has been disabled. This one has been disabled. If I come here, it should say under logs unapplied. You see this policy has been unapplied here. Did I unapply the JSON also? Where is it? This is XML threat protection unapplied. This one, oh, this one didn't disable it. Okay, what is this? And let's see. Okay, now both of them are disabled. Okay. Find. Just let me start this. Go down. Yeah, it says here at the end and applied here. So both of them have been removed. Now let's send requests to that application with some dummy payloads. It is here, which one? It is this one. So JSON XML threat protection API data JSON. Let's send to the JSON resource first. And the body. Actually, okay, yeah. Let me remove this. Let's add some dummy JSON here. And we can add, for example, from I have this airport JSON. I will add just one airport. So now under here, the data type I have select JSON. Now when I send this request, it will give me the same data because this data, the last return was the original payload. I have to remove this comma. Now send. As you can see, I get the same data. And now let's add JSON protection and modify the JSON we send and see how it behaves. So JSON threat protection, I will enable it. And we'll see also the configuration. So by default, I think it is better to remove it and do that. Let's do it together. Remove, add policy, and security. JSON threat protection is here. So by default, these values are -1. That means there is no any limit. So you specify whatever number you want. So let's understand what each one of them are. Here, maximum container depth. The second one, maximum string value length. The third one, maximum object entry name length. Maximum object entry count. Maximum array element count. And the advanced is the same like before. So let's change a couple of them first. So for example, this maximum string value length is the length of the value, and maximum object entry name length is the length of the key. So in our case, let's see in what we sent, we have the airport, how many characters? Let's just make it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 with a space, 11, 12, 13, 14, 15, 16, 17. Okay, so I can make that 20. So maximum object entry name length, it should not go more than 25, let's say even. Because we can have other airports with longer names. String value, and oh, this is the value. I'm sorry, it's the value. The object entry name is the key. So let's make this 10. And object entry count is this one. So I have 1, 2, 3, 4, 5, 6. So I have 6. Now I will make that, let's say, 8. And if you have an array also, you can specify in the array. And this depth is important. Right now, we don't have the depth is just 1, but under, for example, name, you can have another object which has its own key value pairs. So let's try with this one first, and then we'll test the devs. So apply this. Apply policies. Okay, let me first take a screenshot of this so that we can see what we have done. So these are the 3 policies we have applied so far. Oh, I need starting from here. Okay, perfect. Okay, save. I mean, apply. Go to runtime manager, remove JSON from here. It will update itself. Okay, this is saying unapplied. This is from the previous one. So, apply, right? Yeah, you see it is active here. So if it is disabled, it becomes shaded gray. The background is gray, it becomes shaded like this. So this is enabled, that is. Okay, you see it here. Applied policy JSON thread protection. So now we can test it. Let's go test and send. It works fine. Let's start twisting one of them. For example, let's twist the string value. So remember, this is a value and the name is the key. So the value threshold is maximum of 25. Now let's change it to something else. Just add some string. Send. It says string value length has been exceeded. Maximum allowed is 25. So that is one. The other one is this one. The name cannot be more than 10. So let's see, for example, this T-zone, I will call it appropriate time zone name, something like that. So more than 10. As you can see, field name maximum length has been exceeded. Maximum allowed is 10. So let me undo that. 2. So we have tested 2 of them so far. We have tested this one and this one. Now let's test this one. How many object entry counts do we have? We have 1, 2, 3, 4, 5, 6. Let's add another one. 7. T1. T1. Value 1. So this is just dummy data. Let me use double quotes in this of the rest. And I will copy paste this a couple of times. Okay. I guess these are more than 10 already. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Adding 11 1. Okay. So key 1, key 2, key 3, key 4, key 5, value 1, value 2, value 3, value 4, and value 5. Send. Oh yeah, I need commas. Perfect. Send. So object entry count has been exceeded. Maximum allowed is 8, but these are above 8. So this JSON thread protection is it helps us to make sure that data with the, or in other words, it helps us to protect inflated data from being sent to your application and causing your application to encounter problems. Now let's see the other one. The other one was related to devs and will be done with JSON thread protection. Let's edit it again. And there is this maximum container devs. Let's just make it 2. save. So I will add another devs here. So this one time zone, I will make it, I will add another key called time zone. And make it an object and text this there. So this is of devs 2. It should work fine. If I add another devs, it will fail. We have this top level up to here, up to this time zone, and we have the other level here. Can just count the number of closing curly braces or opening curly braces on this side. So let's see if this has been applied. I guess this is this one, so it has been applied already. Now, if I send a request with this one, it should work. It should work. Now I will add another field here. So related to time zone, what can I say? Compared to UTC, just don't worry about the key, the meaning here. Compared to UTC, I'm adding a sub level. So here, name one, it doesn't matter. Just let's add something value one. So we have 3. This is of devs 3. We have level 1, 2 up to here, and the third one is you can count 1, 2, 3, or 1, 2, 3. Now, if I send this request, you see failed, name maximum length has been exceeded. Maximum the name maximum length, which one is it? Oh, this one. Okay, I will call it just let me call it etc. First, it failed here even before checking the devs. Send. So now container devs has been exceeded. Maximum allowed is 2. So that's it. Before break, I want to cover another. So the XML thread protection is also the same thing, similar to that. You can test it yourself, just for the sake of time. But I want to quickly show you also this one, the spike control. We saw this yesterday, but the frequently asked questions section here is very informative. I encourage you to read it. And there are this in the settings here. What does each response header mean? There is here, and you can encounter questions, such questions. X rate limit remaining, this is the amount of quota currently available. The X rate limit, the maximum available request per window. So this is the limit per window, the available the maximum available requests per window is this one, whereas this one is what is remaining out of it. And this one, rate limit reset, is the time for it to be reset in milliseconds. If it has not reached the quota yet, this will be 0. Let's just spend a couple of minutes and test that. So we have with the other application, let's get to the other one here under policies. I will enable this. Not only that, I will also make sure this is checked. Expose headers. So if this is checked, it will give those information. Otherwise, you will not see them in the response. So save. And this is the application. Okay, I just want to see in the headers. So the headers now will change. You see, we have 6. Now, when I send requests, once this new policy is applied, the key value pairs, the count of key value pairs on this page will increase. Send. Let's see if that policy applied. Go here. It is this one. Under logged. Yep, you see it is applied here. Applied spike control here. Okay. So let me send again. It is under headers. I mean, yeah, headers here, headers here in the response, not in the request, in the response here, the lower one. Send. You see here, okay. You see here we have the limit. It is 3 because, and out of the 3, 2 are remaining. Since the time window available quota has not been exhausted yet, it is 0. This one, the rate limit reset. The reset is the number of milliseconds remaining. So let's send a couple of more requests and you see that changing. Still the reset is 0, 1 is remaining, now 0 is remaining, and you see 654 milliseconds are in the remaining milliseconds for it to be reset. What it is saying, again 0. So yeah, this one also it is good to know. This rate limit, the limit is the number in time window, and remaining is out of that, how many are remaining, and the reset is if the code has been exhausted already in a given time window, what is the time remaining for it to get reset. Okay, now let's go here, what is remaining here. This one we have seen it. I think the order of policies, let me give you 10 minutes break and quickly we'll see the order of policies and endpoint with proxy. Yeah, take 10 minutes break, please. Okay, let's get started again so that we can get time for the Kahoot. I hope if we cover these sections. This REST connect, we are going to see it another time. So now let's quickly see order of policies. And we said the order of policies is opposite for the response. It is opposite of the request. For the response, it is opposite of the request. And the order of the policies is top down. So here we have spike control. I can disable in spike control. We don't need it. Let's have just message logging, client ID enforcement, and header injection. So now under this configuration, let me bring my annotate extension. Okay. So what we are saying is when you send a request, this one, the one on the top in this case, which is, did I disable the spike control? Why is it not given up? Okay. Okay, perfect. Doesn't refresh itself. That makes sense. Okay. So right now for the request, first this one is applied message logging, followed by this one, followed by this one for the request. For the request. Whereas for the response, it is bottom up. So this one has the highest priority, followed by this one, followed by this one. So how can we check this? Since we have message logging here, in the message logging, by moving the message logging around, we can see, like for example, this message logging, if we put it below header injection, since the header will be injected after it is logged, then there will not be headers injected if we put the message logging below that. So we can experiment that way. So clear this. Right now, what do we have in each one of them? Let's see. So, and this is client ID enforcement in the message logging. Let's log. What are we logging? The client ID. We are logging here. I'm just logging the client ID. The client ID is attributes.queryparams.client ID, as you can see. And client ID is client ID enforcement is below it, and there is header injection below the message logging. Actually, the third one here. So what are we logging here? We are logging in the response. We are logging size of payload. So let's send a request and understand in the logs what it looks like. So here we have the logs, and I will send a request. Okay, I will disable also. Yeah, okay, this should work fine. Send. Now let's understand what we have in the logs. So in the logs, you see here the client ID is logged. That is what we sent. And there is the size of the payload. This is from the response that you see here. And this one is from the request. Again, let me check in this one logging. We have two. Oh yeah, we have another one also. So this is after calling. After calling, we are logging the size of the payload, and before calling, we are logging the client ID. So that is what we see here. The client ID is there, and the size of the payload returned is here. Let's move them around now. So now I will move the client ID enforcement. I will make it above the message logging. Let's first send an incorrect log, an incorrect client ID or client secret. So under query parameters, I will change this. I will add A to here to the client ID. So this is incorrect. However, it will get logged because message logging takes place first before client ID enforcement. So send request. Obviously, I will get an error. The payload size in the payload from the response is 1. But if you go to the logs here, you see our client ID is logged. This client ID is logged. Now let's check by moving the client ID enforcement above the message logging. So reorder them. Now, if I move it like this and save this, what happens is the client ID enforcement is first applied. It will check that the client ID is wrong. Then it will not continue to the next one. So the incorrect client ID will not be logged in this case. Apply order. Okay. Let's just give it a couple of seconds and we'll check that. So this client ID now, we will not see it, is basically what I am saying, because client ID enforcement first will check if the client ID is correct, and it will find it incorrect, and just error will be returned without going further downwards. Okay, this has been applied. So send request. Invalid client. So if you come here, we don't see any logs, as you can see. Before, when I was sending incorrect client ID, I was seeing what client ID was sent. Let's start by first sending a correct one. If we send a correct one, it will get logged and we'll get response. And it got logged, as you can see, the client ID is this one. And this rest of it is also logged. But if the client ID enforcement is on the top, that means it has the highest priority, and either a client ID or client secret is wrong. Now nothing gets logged. As you can see, nothing gets logged. Since this is in the request part. Now let's understand in the response part. In the response part, okay. So in the response part, we said, in the response part, we said it starts from the bottom. So header injection has the highest priority, followed by message logging. Yeah, that is it. So let's just now, if we see this one, then in the headers, let's log, after calling the API, let's log the headers, for example. We can do that. If you see here, we are adding a header called, what's the header? We are adding the size of the payload, we are adding it in the outbound header. So that means in the response header. So that also we want to log it, and we want to see when it gets logged and when it doesn't by moving this, the message logging and the header injection around. So in the message logging, I would edit this, and after calling the API, I will just edit this one. The header is the response header is, then come here. I guess I can simply just put attributes dot headers. I hope I don't have any typos. Yeah, like this. So we'll see the whole header. Okay, apply this. So now what will happen is, since there is a header being added first in this header injection first, in this order, the added header, we should see it in the logs. However, if the message logging is below the header injection, the injected header will not be logged, but in our response, we will see the injected header, is what we are saying. Let's check that. So this one has been applied. Send a request now. Okay, I'll correct this. I added this A. Remove it. Okay, now if we come, what do we see? Okay. Bear with me. The client ID, I see it here. Size. Maybe I will put the specific name of the header. Yeah, let me put the specific name of the header here rather than the whole headers. So the header name is size. Yeah, size. So in the logging, after calling the API, which is in here, I will add attributes.headers dot size, like this. So I have two square brackets on this side, and we can add some string also here, and the size is attributes.header size as a string. Default 0. Let's see. So let's see if it prints this header, if it includes it in the logs. And when we move the message logging below the header injection, we should not see it. But right now we should see it. The new policy applied. Let's see. Send request. What do I see in the logs? Client ID. Okay, I see here. Okay, it is just being applied right now. Applied policy message logging. Okay, so let's send the request again. If I come here, I see client ID is here. Yeah, here it is. And the size is, this one is what I included in the logs, in the response. Yeah, if we see them here in the logs, what we have in the request, we are logging the query params. I mean, the client ID, yeah, client ID from the query param, as you can see, before calling API. After querying API, we are logging this one. And the size is attributes.header size. So that is what it is showing here, that is here. And the size is 196. Now let's move them around. You'll see that one now will not get printed. So if reorder them, message logging, I will put it to the bottom. That means it has the highest priority in the response, right? In the request, it is the last, but in the response, it has the highest priority. So apply logs. Basically, they are opposite. One is the request is going downward, so the policies on the top will have highest priority, whereas in the response, the policies that it gets in the bottom will have highest priority first, second, third, and here first, second, third. This is for the request, and this is for the response, is what we are saying. Until this gets updated. Okay, let's see. Yep, the logs have this new policy has been applied. Now we can check. We will not see this the size, this one, like we should not see the size information, basically, which is, where is it? 196. Let's say information. Yeah, this one. Now we should not see this part that was getting logged before. Send. Let's see, what do we see? The client ID, we see this. This one is from the request part before calling the API. However, after calling the API from the response, since that header doesn't exist, nothing gets logged. Is what we are seeing. So send multiple requests. This is the client ID being logged. That's the header, the injected header, it is not being logged. So practice with this one. It is very interesting. If you practice it, you will understand it better. If you have some ambiguities, you can also ask questions in the Telegram group we have. But such things, you learn them better through practice. I have two questions related to the order in the CAUT questions that we are going to see later. I have last one for today for the policies. So in the policy section, we have a couple of policies that we have not yet seen. This one is in light blue. We'll see them another time. The caching, OAuth 2.0, dashboarding, custom policies, and custom alerts and so on. We'll see another time with our next project. As our project gets more and more real world, we will first apply these policies and we will see new policies also. But we have this automated policies. So automated policies basically means, like, let me show you, let's remove all these policies right now. Remove or disable them. That is better. Disabled. Refresh this to see if all have been disabled. Okay, all of them grayed out. So now I can send requests without client ID and client secret, and it should work fine. And there is authentication denied. Oh yeah, it takes some time to get applied. Basically, that's it. The other one also, this one, I will disable any policies it has. The JSON thread protection. I think until that, I can quickly explain this one. I was experimenting with this one and edit. Please practice this one. You have the node depths, the count, the attribute count. So this is attributes that we have been working with. To access attributes, like in DataWeb, for example, we were using dot @ sign in the attribute name. So this is count of attributes, child count, text maximum length. Also, not only the count of the attributes, but the length of the attributes also. And usually in XML, we put comments, and the length of the comments also you can control it. But -1 here means there is no any limit. I was just practicing with this, that's why this is 2. So this one you can practice. For now, I will disable both of them. So there is no any policy applied now. I can just make many requests. Then we'll apply environment level policy, which are automated policies. So any API in that environment will have by default those policies applied to it. So by now it should be applied. All of them have been removed, I hope. So I see data, I see there isn't any client ID here included, as you can see in the query params, or in the headers also, we don't have anything. So this is authorization is removed. So as you can see, there is nothing. But if you go to the environment, under policies, you can add, here you see automated policies. So under automated policies, you see here, apply policies to manage security, control traffic, and improve adaptability of your APIs. And there is automated policies here. Here what you see are API level policies, because I am in this API. But if you just go to a higher level and get back here, in here, you have automated policies. Click here, add automated policy. Let's add client ID enforcement, for example. So every API, by default, will have at least this one, client ID enforcement policy applied to it. And then if you apply other policies specific to it also, in addition to this one, all policies should be fulfilled based on the order that they are put. So this one, let's leave it like headers, or let me make this query params. Query params. Here also the same way, because I have the secret client ID and client secret in Postman as query params. That's why I'm changing this to query params. So if I apply now both of my APIs will have this policy applied to them. If you go to specific policy, okay, API groups, API administration, these are the APIs. If you come here, under policies, now we see an automated policy, and you cannot remove it here, I guess. Yeah, you cannot remove it here. You cannot remove it by going to a specific policy. Rather, you can remove it from the home page. So this, you see, you have the automated policy. And if you have this automated policy, you cannot add same policy again. And here it says this policy will not be applied because it is already applied as an automated policy, it says. So this is how we apply automated policies, just by coming here, and then here we have automated policies, and you can add as many policies as you want that you want to be applied across all of the APIs you have. Let's test now. Now it should give an error if I send without client ID enforcement, without the client ID and the client secret. So we have them in the params here, query params. Send, authentication denied. But if I just check this, it will work fine. Yes. So that is about automated policies. We just get them in API Manager before we go to specific APIs under API administration. Before you click any API, you have automated policies here. Okay, and we'll see custom policies another time. Now let's continue to the next topic, which is endpoint with proxy. Very important topic. So we'll make this slideshow. So let's start with the question, what is a proxy? Move this here. See here, an API proxy functions as an intermediary between the external applications and the backend server. So you have your implementation. The implementation layer means this is what is running in Runtime Manager, your project that you developed. So it is in the backend, right? And there is an API gateway. So this in the API gateway, we have a proxy. This proxy is an intermediary between this backend and the users. So users or clients, they interact with the proxy, and the proxy validates the requests, checks everything is fine, and then if it is fine, it sends the requests to the backend. So what is the difference between using auto-discovery and the API proxy is what we are going to understand. So here it says, your backend can be a non-mail application. So we use auto-discovery with mail applications. But if you have non-mail application and you want to integrate it to your other applications, you use API proxy. So your backend non-mail application is here, and you have API proxy, then you can monitor it in API Manager and integrate it with your other applications. Your proxy application is then automatically tracked by API Manager. See, this is what it says, automatically tracked by API Manager. You don't need to add client ID and client secret or auto-discovery client ID. And the client application or consumer calls the proxy, like we say, it calls this proxy, it interacts with this proxy. And the proxy then forwards the call to the API implementation, which is this implementation. Let's see more information here. So if you see in this page, we have in the API proxy, we have API gateway. What is the API gateway? Let's see in the next slide. And they have added documentation link for API gateway. So the API gateway determines which traffic is allowed to pass through the API to the backend service. So it checks which traffic is allowed to pass through the proxy to the backend service towards the actual implementation. And also it meters the traffic flowing through it to the backend. And it logs all transactions, collecting and tracking analytics data. It applies runtime policies to enforce governance, like rate limiting, throttling, and caching. We have not seen these ones yet. We'll see the similarities and differences between throttling and rate limiting, and we'll see also what caching is. So we deploy proxies to API gateway runtime using API Manager. That is what we are going to see. We deploy proxies to API gateway runtime using API Manager. So when we created an API in API Manager, we were using basic endpoint. Now we are going to select endpoint with proxy. So when do we use basic endpoint and when do we use endpoint with proxy? You see the differences between the two here. So the basic endpoint, let's start with basic endpoint. The basic endpoint is more resource optimal. So when resource usage must be minimized as much as possible, we use basic endpoint. Why? Because the proxy endpoint, it is creating another layer, so it will use more resources, more vCores. vCore means like the memory capacity of the instances. And Microsoft charges you by the amount of vCores you use. And if you create a copy of your application, you are using more vCores, more workers, and only one application can run in a given worker. Only one application can run in a given worker. So if you are to create a copy of it, you will have to add another worker. So it becomes more cost, it becomes costly from this regard. And also deployment is easier, as you have seen with the basic endpoint, deployment is easier. We'll see CI/CD with deployment architecture, and CI/CD must be as simple as possible. In that case, if you want the deployment to be smooth and easier, we use basic endpoint. But proxy endpoint also has its own application. As we said, for non-wheel APIs, if you want to bring them, to manage them using endpoint platform, you use a proxy endpoint. So your non-wheel app should be secure, the first thing, because this alone will not secure it. But on the MuleSoft side, on the endpoint platform side, once you have the proxy, you'll be able to manage it from API manager. Also, there are times where you have to apply special security checks or network configurations. In that case, proxy application is used. And the other thing is, so for this basic endpoint, we use it auto discovery, right? We included the client ID, client secret, and do the ID for the auto discovery. What if you just have the implementation without this information and you cannot do anything? You just have a closed code. If you have a just closed code where you cannot apply auto discovery, then you can use a proxy. Okay, so I have a couple of questions, but first, before we do that, let's see in API Manager, let's create an API with API proxy. Then we'll see questions, and we have some code related to that. These are common questions. It sounds first confusing, but as you read more and practice more, you will understand it well. So this Dowry Schools API, I will delete it. I will delete any API I have here actually, or maybe let me delete the other one, the easier one. This one, because it will not take time to deploy. Setting, delete, application is deleted. I'll go to API Manager also. It is this one. You will see now I will not need to add any ID or add client ID and client secret. So this has its own security benefits because your client ID and client secret will not be exposed. Okay, perfect. But if you go this code, this RAML code, I have pushed it to Exchange because I want to create the API instance from Exchange. It is this one. So now, okay. Okay. And here in an endpoint platform, I want to remove auto discovery. Yeah, endpoint studio. I mean. Removing this configuration, plus I don't need also the client ID and client secret. So endpoint platform. API manager, I mean, is under API manager. So I will remove it also, client close. Now let's deploy it. Save this. So I didn't add any keys. Now right click here and go to any point platform, deploy it Cloud Hub. Comes here. So there is new Cloud Hub 2.0. It has shared space. This is relatively new. If you go to Cloud Hub 2.0, this one we will see at some point while this is the end, we will have a couple of classes called miscellaneous, and we will cover different things. But right now, among that will be the Cloud Hub 2.0, but right now we are pushing to Cloud Hub, okay? And when you push like this, if you come to properties, if you have added client ID and client secret, you see them, they get added here. But now nothing has been added because I removed them. So now deploy. So once this gets deployed, we need the implementation URL to include it in when we create the API proxy in API Manager. Let's see how long this will take. Okay, until it gets deployed, let's couple of other things. So now we can even answer these two questions, I think. This one, let's leave it. Let's answer this question. A mail application has been deployed to Cloud Hub and now needs to be governed. IT will not allocate additional vehicles, see? So that means they want to be more economical, so they cannot add additional vehicles because you get charged by the amount of vehicles. Is it 0.1 vehicle, 1 vehicle, 1.5, and so on? When you deploy, you see that in the drop down. So the vehicle is, we have them here. So in the drop down, you see different vehicles. We'll discuss another time the cost of the different vehicles. Should you use bigger ones or many small ones and so on? But you get charged by the number of vehicles. So as much as possible, you want to be optimal. So here it says a mail application has been deployed to Cloud Hub and now needs to be governed by IT. IT will not allocate additional vehicles for a new mail application to act as an API proxy. So what it is saying is they will not create, they are not willing, they don't allow it to create an API proxy because that will take more vehicles and that means more cost. So the question is, what should be done to or with the mail application to preserve the current vehicle usage while still allowing the mail application to be managed by API manager? So you don't want to add additional vehicles, you don't want to add additional resources, you don't want to spend more money, but you want to manage it. What can you do? What do you have to do? A, upload the mail application's jar file to the API instance in API manager. B, modify the mail application to use auto discovery to register with API manager. C, deploy the mail application behind a VPC and configure the VPC to connect to API manager. D, register the mail application in runtime manager to connect to API manager. Can you share your answers in the chat? So basically, you just might want to manage an API, but you don't want to use API proxy. So you have two options, either to use API proxy. I'm sorry. So if you don't want to use API proxy because API proxy uses additional resources, what is the other option you have to manage it? Is what this is saying. So when you create an API manager, you use an endpoint without proxy, and to enable that, you have to see how many answers. Okay, so we have seen the two options to deploy, right, and to manage APIs. Oh, with proxy we will still see, but what this is saying is, yeah, you don't want to create proxies, so you want to manage it using basic endpoint. And to be able to manage it with basic endpoint, API manager and runtime manager have to be able to communicate. And for them to communicate, you have to add an API ID in your implementation. You have to add the API ID that you get from API manager in your implementation, include also the client ID and the client secret. So that helps to enable auto discovery. So the answer is modify the application to use auto discovery to register with API manager. Yeah, read it again and it will make sense. So from the two options, if you are not using API proxies, the other option you have to manage it is to use auto discovery. Because if you are using API proxy, we say it manages it automatically. API manager manages it automatically using the gateway. And if you are not using API proxy, then you have to use auto discovery so that your application can be managed, so that your application in your implementation in runtime manager can get the policies, can download the policies from API manager. Okay, now I hope my deployment is done. So this one is done. So now we come to API manager and we go to add API. Oh, by the way, this one I forgot last time. So under add API, we say you have this add new API. If it is add new API, we are working with this one, Milk Gateway. Service mesh and the Flex Gateway also. This one especially is new. We'll discuss them another time, but the most common one we are going with is the Milk Gateway. Here, if you see, we have basic endpoint versus proxy application. So now we work with proxy application. But to create the, once you select your application, if you click next here, either you can bring your application specification from Exchange or upload the YAML file yourself. We have seen this one. The other option you have is import API from zip file, and the zip file is not what gets downloaded from Exchange, but rather from here. Like this one, we can download it here. If you go under actions and you see what the contents look like, there is export somewhere here, export API. It is a very simple content. So it is this one. See inside it, it has this export the JSON file. If you see the information it contains, if someone gives you this information, this zip file, you can import it. This is the zip file that you can import when you create by uploading zip file. Okay, so but now let's create an API with API proxy endpoint using specifications in Exchange, because I have pushed this one to Exchange from Design Center. So go here, add new, Milk Gateway like before. Now, not basic endpoint. It is this basic endpoint that you need auto discovery. See, it is even here specified. Connect your API to a Milk application using auto discovery. So I will select this one. Select a deployment target and deploy a new Milk application to serve as a proxy. So you select the runtime version. We are using 4.4. Proxy app name. So this one, I will call it my app proxy. Okay, use lowercase letters, numbers, and dash. Avoid starting with dash. Internal or ending with dash. Okay, click next. Now it is this one. This one is selected by default. Select API from Exchange. If you have it in your computer, you select this. If you have the specification, the RAM specification in your computer, you can select this and upload it. So I will select this one because the implementation is for this specification. And here, by default, it detects it. It is RAM, the version. It pre-populates this one from what is there in Exchange. Click next. It is HTTP. Here, there is implementation URL. So implementation, you see this API instance level and consumer endpoint are optional, whereas this implementation URL is not optional. So this implementation URL means if I go to runtime manager, it means the implementation of the backend. So in our Google Slides here, it is the implementation of this one. I want to keep the implementation of this one so that it can create a copy of that and have it here as an intermediate layer, and consumers or clients will interact with the intermediate layer rather than with the backend. So the implementation is click here, and if you go to settings, you will get it API, this one. Select it and HTTP, okay. HTTP. So this is implementation URL and it is HTTP port 8081. I will leave all of this. And under advanced option is proxy version. Just leave the letters. I will leave all these defaults for now. Next. save and deploy at the end. This is save and deploy. So it is deploying an application, a proxy application, and it will take additional resources, additional vCores. You can see this is the gateway, mule gateway, it is proxy, the runtime version, and other things. Save and deploy. So what do you see here? Now it is going to deploy an application to Runtime Manager. If we come to Runtime Manager, it generated an IP instance ID, as you can see here, and it is going to make it active by itself without us adding it to our implementation in Endpoint Studio. Your API is being deployed to Mule 4.4 Cloud Hub. It says here, now it is unregistered, but after some time, once it is deployed, it is going to be active. And the proxy URL is here. So it is a different URL than the implementation URL. The implementation URL is here, and you want consumers to interact with this one, not with this one. You want to give them the proxy URL, not the implementation URL. Okay, I think until this gets deployed, we can see it later. Let's have the Kahoot session. So quickly summarize, because I have a couple of questions in the Kahoot. Let me quickly review this, and you will be good to answer that. Automated policies, we have seen it applies to all APIs. You have an API manager. This one is easy. So this is at a high level for all applications. And about endpoint proxy, we say it functions as an intermediate layer, and it helps us even to manage non-Mule applications. Auto-discovery works with Mule applications only. And you need that when you have non-Mule applications, or even if you have Mule application, if you don't have the code and if you cannot apply auto-discovery, also you use proxy. And in proxy, it has API gateway. This API gateway manages the traffic, what should be passed, it meters them, it logs, and it validates, and so on. So when clients send requests, first it interacts with the proxy, and the proxy after the traffic is validated by the gateway, it gets passed to the backend or the implementation, and the response gets returned. So it is for the requests that the API gateway validators, not for the responses. So this ones we have seen that when to use each one of them, we say the basic endpoint is more economical, smoother, it uses less resources, whereas the proxy, you need it when you have non-Mule applications or when you need special configurations, special security concerns, when you have special security concerns, or when you need when you cannot apply auto-discovery because your code is closed code. So let's go to Kahoot. Try it. Oh my goodness. Okay. Let's start it. Line policies too. True or false? Automated policies are applied to API instances of all APIs. The API instances of all APIs means you have the APIs here are the implementations, and the API instances are what you have in API manager. So it is saying the automated policies are applied to all of them. Yes, they are applied to all of them. Next. Proxy endpoint API instance points to which application? Does it point to the implementation, to the actual implementation, or does it point to auto-generated proxy application, or to both? So when we say auto-generated proxy application, we say when we deploy it using the proxy endpoint, it deploys another application of the implementation. So what we are saying is, this could be a little bit confusing. Let me explain. What we are saying here is, the question is, so you have the implementation here. This is the actual implementation. And you have a proxy here. This is auto-generated. You don't do anything with it. You just select the endpoint with proxy, and you give it the implementation URL for this one. So the question is, these clients that send requests, do they interact with this one, with the backend, or do they interact with this one? They interact with the auto-generated proxy, is what it's saying. So I want you to remember that auto-generated proxy application is the answer. Next. Basic endpoint API instance points to which application? If it is basic endpoint, on the other hand, it points, there is no proxy here, so it points to the actual implementation. You don't have an additional intermediary layer. It just points to the API implementation. So they are opposite, you have to remember this. Basic endpoint to the actual implementation, whereas proxy endpoint to the auto-generated auto-generated proxy implementation. Okay, this is like yesterday, longer, so I took a screenshot. You have longer time, I think, about 1 minute. Let's assume two policies are applied to an API instance. Policy 1 is higher order policy. It is basic authentication. And policy 2 is below it. It is JSON thread protection. What happens when client sends a post request to the API? What's the order? Oh, yeah, I'm sorry. I think the time, I made the time. I think I didn't put this up properly. I apologize for that. So this question, I can show you here. I have it here. It is this one. So let's assume two policies are applied to an API instance. Policy 1, it is on the top. So that is why it is higher order policy. It is basic authentication policy. And policy 2, below it, it is lower order policy, is JSON thread protection policy. What happens when client sends a post request to the API? What is order? The order when a client sends a post request, is it 1-2 or 2-1 was the question? So basically, if it is in the request part, the order of the applications is 1-2. This is my answer. My question is not complete, I think. Whereas when it is for the response, it is 2-1. I have another question here, which is the opposite. So here, let's read this one. Yeah, request 1. Let's read this one. Let's assume two policies are applied to an API instance. This is the opposite of the previous one, and they have it in the cloud. That's why I'm reading it here. So the policy 1 is message logging policy with after calling API. And policy 2, lower order policy, is header injection policy. This is what we just saw with outbound header map configure. So this is, we are adding header injection for the response basically. What happens when API sends response to client? What is the order of impact? Is it 1-2 or 2-1? When we say higher order policy now, this is on the top. Message logging is on the top. In the order, if you see, message logging is on the top. And below it is the header injection. So basically, in the logs, will you see a header injected is a question. Will you see a header injected? So the order, is it 1-2 or 2-1? Basically, we tested this one. And if we make the header injection above the message logging, we didn't see the header logged. But if we put the header injection before the message logging, since first header gets injected, then in the logs we saw header. So the order of this one should be the opposite of the previous one. And I have that question here. Let's see. Yeah, it is because count doesn't allow to include elaborate or longer string. So that is what made my question like incomplete. Sorry for that. Okay, next question, true or false? JSON thread protection policy provides protection from inflated requests. Inflated means either long keys, long values, or lots of key value pairs, or deep nested JSON. That is what inflated means. So the answer is yes. That is why we use JSON thread protection. It helps us to protect bad actors from crashing our applications by sending inflated JSON requests. Next question. In JSON threat protection policy, what's the role of maximum object entry count configuration? To specify the depth, to specify the maximum number of entries in an object, to specify the maximum number of entries in an array, to specify the maximum length of the keys and values. So you just remember maximum object entry count. You see count and object. So yes, so to specify the maximum number of entries in an object. Entries in an object means this ones. The maximum object entry count means if you go to the body, oh, I didn't have JSON. Let's see. I should have some JSON somewhere. Airports.csv and the airports JSON is usually around here. No. Okay, here it is. Oh, something else. Can go to the folder and open it. Okay, have it. So, and this airport is, for example, this one, the count is, as you can see, 1, 2, 3, 4, 5, 6. That is what this means. So maximum object entry count, it means that we have 6 in this case. So experiment with these ones. When you experiment them, you like it. Next question. What does an API proxy application not do? So you have 1 minute here. These ones are long, you can think. What does an API proxy application not do? Determine which request mule event is allowed to pass through the API backend service. Apply runtime policies to enforce governance. Determine which response mule event is allowed to pass through to the API backend service. Meter the traffic flowing through the proxy. There is request and response here. They are opposite, A and C, C, A and C. So the API proxy, which means with its gateway, does it control the request or the response also? We say it applies policies, it meters traffic, it validates request traffic, and it logs analytics, but it doesn't validate responses. And there is no need even to validate responses in this case. So the answer is, how do you see the questions? Do you know how you can see them? Is it possible? Okay, yeah, show me. Thank you. So you see it here. So it is this slide. Go over this slide to understand it better. So it determines which traffic is allowed to pass through the API to the backend service. Okay, perfect. It measures the traffic flowing through it, logs all transactions, collecting and tracking analytics data, applies runtime policies to enforce government like rate limiting, throttling, and caching. However, it doesn't validate responses. It is requests that it validates, right? In here, if you see, there are clients here sending requests. It validates whether it should be sent to the backend or not. Once the backend sends the response, then it just sends it to the clients. So the answer from that perspective, if you see here, determine which response mule event is allowed to pass through the API backend service. So this is the catch response. Whereas here it is request. Usually, if you have multiple choice, if you have request and response, think about what's in it. Probably one of them is answer. Okay. Let's go next. We're almost done, and I think we'll stop there. What is the purpose of API auto discovery? This one, we are seeing it in multiple ways. By now, you should remember it very well. A, enables API manager to discover the published API on any point exchange. B, allows a deployed mule application to connect with API manager to download policies and act as its own proxy. C, it acts as its own proxy. C allows the meal application to be automatically discovered on endpoint exchange. D enables an API to be directly managed in API Manager. With auto discovery, just forget exchange. If you see exchange, exchange is for to host your assets so that others can discover it, not for managing. Exchange is not for managing. For managing is API Manager with auto discovery. So show media. Let's see show media here. Let's see them one by one. Just forget this and forget this. Now read this one. Allows a deployed meal application. This deployed meal application is in runtime manager. If it doesn't communicate with API Manager, you cannot apply policies to it. And for it to communicate with API Manager, you add the ID for auto discovery. And then at that time, the deployed application, which is the implementation in runtime manager, will download the policies and apply them. Even you saw, even it applied it to my local to my local application. When I deployed it, since I had auto discovery enabled, when I just deployed it in Anypoint Studio and tried in Postman, it said authentication denied because client ID enforcement was enabled. The other key term here is with auto discovery, it acts as its own proxy. So in this case, the deployed meal application, it just acts as its own proxy. See here, we have a proxy communicating with the backend, but when you have auto discovery, this part is not there, this intermediate is not there. So the implementation itself acts as its own proxy. You have to remember that. It acts as its own proxy. Next question. Almost there. Next. API Manager has been configured to enforce an SLA service level agreement policy, and the RAML spec has been updated with the required client ID and the client secret header requirements. The new RAML spec has been published to Endpoint Extend. What's the next step to gain access to the API? Once we have an API, how do we get access to it? This one we didn't really see in detail. We'll see it next time. But for people to request access to your application, they have, I was just requesting myself. I was requesting from Exchange to request access. You have to request from Exchange. External users can also request. If they have the link to your public portal, they should be able to send you a request and either you approve it or you disapprove it. So if you approve it, then they can use it. And under the contractors in API Manager, you can see who is using your APIs. So the answer in this case is, see, they can come request access to the API in any point, Exchange. And yeah, if you want to add them to your environment, also you can add them as collaborators. So they can either request either from the public portal or from Exchange. In Exchange, the public portal is also in Exchange. Okay, once you make it public. Let me remove the next 11 of 12. This one, maybe you misheard me. I said it a couple of times. How many meal applications can run on a Cloud Hub worker? You have a Cloud Hub worker. How many meal applications? Can you run multiple meal applications in a given Cloud Hub worker? Or is it at most one? Or is it at least one? So this is in Cloud Hub. So I want to say a couple of things here. That's why I included it here. So if you forget it also, that's fine. I will explain it. So a Cloud Hub worker, let's see what a Cloud Hub worker here is. Basically, Cloud Hub worker, think of a computer with some memory and compute capabilities. And if it is in Cloud Hub, you can apply only one meal application. That is what we say when you create a proxy, you are adding a worker, another worker that has its own beacons, and you get charged according to the beacons. So that means you incur more cost when you use proxy. Whereas if it is on premise in your own computers, in your own cluster, you can deploy multiple. We'll see that also. You can deploy multiple applications in a given worker. In Cloud Hub, however, you have to always remember, in Cloud Hub, in a worker, you can deploy at most one application. Okay, that is why using proxy becomes more expensive. But in other environments outside of Cloud Hub, both the proxy, you can deploy both the proxy and the implementation in the same worker. In that case, the cost would be different. Okay. Next, last one. What does the mule runtime use to enforce policies and limit access to APIs? Endpoint access control, the proxy created by API manager, the mule runtime is embedded API gateway. This one is a little bit confusing. Spend time thinking about that. Perfect. So let's see what this is saying is, I will close this. So here we said, what did we say here? So the API gateway, we use the API manager to deploy proxies to API gateway. Let me close this. Let me clean this first. So API manager, we use it to deploy proxies to API gateway. And when we use auto discovery, the implementation itself acts as its own proxy. Whereas the API gateway, you see here, the API gateway in the proxy layer enforces policies. These policies, different kinds of policies. So the policies in this layer, the policies and the metering and the logs, everything is handled by the API gateway, not by API manager. API manager is used to deploy the endpoint with proxy and also to apply the policies. I mean, to select which policies you want to apply. Once you select them, once you specify, once you choose which policies you want to apply, the gateway takes care of that. The API gateway takes care of that. That is what this slide says. So you can revisit that. And if we see this slide, what does the runtime use to enforce policies and limit access to APIs? The mule runtime is embedded API gateway, not API manager, or not the proxy created by API manager. It is the gateway that is found in the proxy. So the API gateway. And they understand the difference between proxy, API manager, and API gateway. You use API manager to deploy to API gateway proxy. And in API manager also, we will see you choose what policies you want to apply, and the API gateway enforces those policies and meters the traffic and so on. So this has been lots of information yesterday and today. So I really appreciate all of you for attending these classes. I hope you spend enough time to study this. If you don't study it now, since we are going to add more, you may forget it. And the other thing is, by now, the content that we have covered so far should be more than enough to prepare for certification. So I'm planning to allocate 1 or 2 classes and go over the practice questionnaires for the certification. We do them all of us together, discuss, and I also point you where the slides or the content from our class for each question where you can get it. So we will have, I think there are 2 practice questionnaires that I know. We will do this practice questionnaires, but by now what we have covered so far is more than enough to prepare for the certification, and also prepare, think of also preparing for interviews, which needs studying, and if identify your gaps and start allocating enough time to study these resources. I think I took 10 more minutes. This is enough for today. But remember, on Friday, since we just deployed this, our proxy application, you see it now, it is active. We didn't do anything. We didn't add the API instance, the ID in our implementation, and also it is active here. The other thing is, now if you go to Runtime Manager, you will see another copy of the API deployed there. I will see the proxy. See here, I called it my app proxy. So this proxy is a proxy of this one. The first implementation, the actual implementation is this one, and this one is the implementation, the proxy, which will act as a middle layer here. As a middle layer here. This is the implementation, the proxy. So we will discuss this on Friday, and how questions only related to proxies, related to topics that we have covered today. Maybe it is good also if a little bit we practice this one, this XML threat protection. So on Friday, we should spend less than I hope 40 minutes to cover the proxy and this content. And then Saturday, we will get back to our other project. So now, by the way, I hope these things, if you are closely following and if you are studying things now, maybe if in the beginning some things you were feeling overwhelmed, now they should start to make sense. Like, let me show you what I mean in the, I guess it was under in the introduction. What is means start? Let's see, the Google slide is here. We're talking about API-led connectivity and the different layers. We have these ones. So these ones are what we are going to build now. So now if you see, if you have your data in a couple of databases, you build some application and you deploy it to Cloud Hub. That means you have this layer. After that, you can create other applications that connect to these applications and transform the data, process it. This will be the process APIs layer. And then you can have a lightweight final layer and experience API that gets data from the process API. So most of the heavy lifting is done in the process API. And these 3 layers, it doesn't mean always you need 3 of them. You can have just the process API and the experience API, or sometimes if it is simple one, you can just have even the system API only. So anyway, in our next class starting Saturday, we will build multiple APIs, connect them this way, understand what we are doing. So when we do like this, the theory, get back to starting to the beginning of the slides. Some of the theories that were vague at that time, or even you could not visualize at that time, now it should start to make sense. So you have to cover the content again and again so that you understand it well. But this is enough for today. Thank you very much and have a good week.